So when we're looking at long division and synthetic division, one of the things that I do want to do is give you a couple of strategies that'll help you avoid some of the most common mistakes that students make with long division. But also with the synthetic division, I want to take it maybe a step further than you might have handled it before. Or if you did do one or two like this, it was just one or two. But I want you guys to, think about it and try to be able to apply the concept a little bit further than just the basic doing synthetic division, okay? But first of all, let's start with the long division. Before we deal with polynomial long division, one thing I want you guys to understand is that you learned the process for this in like 3rd grade, okay? If you were to do, say, 374 divided by 9, okay? The process here, 9 doesn't go into 3, 9 does go into 37, so you put a 4 down, and then you multiply, right? 9 times 4 is 36, and then you subtract, and then you bring down, and then you divide again. So 9 goes into 14 once, 1 times 9, you're multiplying, and then you subtract. And then when there's nothing left to bring down, you can write your answer. And if you could write it as 5, and that 5 still has to be divided by the 9, so it's 41 and 5/9. Okay? That's the same process you're using when you're doing polynomial long division. Okay? You're going to divide part of it, then multiply, then subtract, and then bring down. And you're going to keep doing that until there's nothing left to bring down. Okay? Or in other words, until what's down here is smaller than what you're dividing by. And then you simply write your remainder as a fraction. Okay? So that's what we're going to look at doing here with the polynomials. And hopefully address some strategies that will help us do this more carefully and more accurately along the way. Okay? So, first of all, one strategy I would really highly recommend to avoid issues is you'll notice in this cubic that we are dividing, it's 7x cubed minus 4x squared plus 3. There is no linear term in this polynomial. But we do need to account for that place. Alright, if you don't do this, chances are you're going to get things jumbled up a bit, and it's going to cause some confusion, and that's where we get errors, okay? So, the first thing that I would recommend doing here is putting in that place, the x place, okay? Because here's the thing, probably 90% of the issues that I see students have with this whole process are because they're sloppy or disorganized. Okay? If you will keep your work neat and organized, then you just got to do the arithmetic right. Okay? So, we're dividing this polynomial by the x squared plus 3. Okay? Now, does anyone remember kind of how we get going with this? How do we start this process?
X squared goes into x3.
3 goes into 7.
Okay.
This hurts my brain.
You got the right start. We want to look at these two terms, the x squared and the 7x cubed.
So we disregard the 3, right?
What do you mean?
Until the end.
Oh, the plus 3?
Yeah.
Yeah, well, until at the next step, yeah.
So it's x squared goes into x3. 1.
7x.
Okay. Well, it's x to the first.
Yeah.
Okay. And we would need the 7. Okay, so it'd be
7x.
7x.
7x. There we go. All right. Think of it, you're dividing, right? what's 7x cubed divided by x squared?
7x.
It's just going to be 7x, all right? Now, notice, I'm going to put that 7x in the x column, all right? Don't just write it anywhere randomly, because then, as you'll see, you may forget or overlook the fact that you're done, okay? If you keep them in columns like this, it's easy to tell exactly when you're to the point when you need to write your remainder, okay? Now, we've divided, now we've got to multiply it back. And this is where the 3 comes in. So 7x times the x squared is 7x cubed. And 7x times the 3 is 21x. So I'm going to put this again in the x column over here. And now you'll notice, all right, what do we have to do at this point?
Subtract.
We subtract, okay? So I'm going to do 7x cubed minus 7x cubed, that's 0. Negative 4x squared minus nothing is still a negative 4x squared. 0 minus 21x is a minus 21x. And then 3 minus 0 is 3. Okay? And this is kind of the subtraction and bringing down. You can think of that all as one part. Okay? Does that make sense so far? Okay? So now we repeat. Okay?
4.
Okay?
Negative 4.
Negative 4.
All right, good. We're going to have a minus 4 up here. Okay, so now we're multiplying down, so it's a minus 4x squared, and we have a minus 12. And again, we subtract.
0.
Okay, so negative 4x squared minus a negative 4x squared is 0. Negative 21x minus 0 is negative 21x. And 3 minus a negative 12 is a plus 15. Okay? Now notice, we're to the end. Okay? We're to the end of our divisor. There's nothing left to bring down. Also, notice the degree of what we're dividing by is bigger than the degree of what we have left. Okay, so you could think of this as, it's smaller, kind of like the 5 was smaller than the 9. All right, so at this point, we're ready for our remainder. Okay, once the power of what you have left is smaller than the power of what you're dividing, you can write your remainder. So we put plus, what's our remainder? Well, it's minus 21x plus 15 over the x squared plus 3. Whatever you're dividing by will be your denominator. Okay? Just coming back to memory a little bit.
Yeah.
Okay. Really, a lot of this is just the mechanics, making sure you get this down and are careful. Like I said, neat and organized is really a key here. Okay? Let me point out one issue some students have here with this minus 21x plus 15. They'll write their remainder, or they'll write their answer like this. 7x minus 4 minus 21x plus 15 all over x squared plus 3. What is the problem here?
You're not at.
You didn't take the negative all the way out? You didn't adjust the 15 either?
Okay, here when you have a negative in front of a fraction, it would be distributed to both parts of the numerator. Okay? So if you were going to write it that way, you would need to make this a minus 15, as though you factored a negative 1 out of both parts. Okay? Now, here's the deal. I just recommend writing it the way we did the first time. Okay? I mention this because a lot of students do this without thinking, and it ends up being incorrect, okay? So be careful that what's in your head ends up being what's down on paper, okay? Because they're thinking the right thing, they just write it down and don't think about the fact that putting the minus up in front there would apply to the 15 as well, okay? All right, so there's our long division. Let's try a little bit, another practice one here. We have a cubic divided by a quadratic. What should we do first here?
Put it in order.
Okay, let's put them in order. And by order we mean decreasing degree. Okay, so put the 6x cubed first, the 10x squared second, then the x, and then the 8. And we're going to divide that by 2x squared plus 1. Okay? Now, take a minute here, try this one on your own, just to work out the mechanics on your own here, and we'll see how you do. Alright, so we've got Katie's here, and notice everything's nice and neat. We can see here the 2x squared goes into 6x cubed 3x times. Okay, so then we multiply. Common things here, we mess up, we forget to distribute the negative to both parts here. Okay, she didn't write it, but she did do it. X minus 3x is negative 2x. Okay, and then we've got this 10x squared we bring down minus the 2x plus 8. So 10x squared divided by 2x squared is 5. And we have then distribute the 5. So 10x squared plus 5. We will subtract the 10x squared and we'll subtract the 5. And that's how we end up with a negative 2x plus 3 left over. Okay? So we have 3x plus 5 plus this remainder. Okay? Negative 2x plus 3 all over 2x squared plus 1. Okay? Remember, the remainder goes on top of what you are dividing it by. Okay? All right? Good. Good. Now, let's look at synthetic division. Okay?
Oh, this is the bad.
All right. This is a great tool. All right? There's a reason why we cover it, and that's because this tool can be used for really, at least 3 different applications. Okay? We're going to start with the most direct, the most basic application today in division. Okay? That's why it's called synthetic division. You can also use this to help you factor out polynomials that you can't normally factor. Okay? We're going to factor things you can't factor. All right? And then there's also another thing that we can use this for, and that is for evaluating a function. Okay? And so how do we divide to evaluate something? So we'll see here in a couple days. All right? But I want you to look at the process that we're following here. Okay? First of all, understand what we are dividing. Okay? Let me zoom in here a little bit. We've got this polynomial, ax cubed plus bx squared plus cx plus d, and this could go as high a degree as we want. It could go up to x to the 20th if we wanted. Okay? We're dividing it by some binomial x minus k. Couple things to note here. First of all, the coefficient of x is 1, and also the degree of x is 1. Okay? If you've got x squared minus 5, you can't use synthetic division. If you've got a 3x minus 5, you can't, without doing some other stuff, use synthetic division. Okay? So that's kind of the rules for why or when you can use this. Okay? So we have a basic procedure here that if you keep this in mind, it really makes it easy, okay? You have here a vertical pattern, diagonal pattern that they mention here. I like to just kind of summarize this like this. We're going to add down, and we're going to multiply over. Okay? Add down and multiply over. So for example, we've got this polynomial here. It's an x to the fourth minus 10x squared minus 2x plus 4. So the first thing I do here is I'm going to list out the coefficients. You'll notice up here we have the a, b, c, d. Alright? Here I'm going to list out my coefficients. So starting with my x to the fourth, the coefficient is 1. And then what's the coefficient of x cubed? What's the coefficient of x cubed?
0.
0. Okay. 0. And then x squared, we've got negative 10. Alright, be careful. By the way, this, if you were doing in the long division, if you were putting in those placeholders, that actually will help you get into that, because you're in the habit of putting those placeholders in already. It'll help you here as well. Okay? So we have 1, 0, negative 10, then negative 2, and then 4. Okay? And you don't have to write these little powers of x and the constant above this. I like to do it sometimes just to help me keep track of what's what. Okay? But we're going to divide this by x plus 3. Okay? Dividing it by x plus 3. Now notice up in here, this is for dividing by x minus k, and we use the k over here. So you have to think of k as what are we subtracting from x. Alright, so I see an x plus 3, so I have to think, okay, that's x minus what?
A negative 3.
A negative 3, okay? Again, a very, very common mistake students make. It's usually not the process that students make mistakes with. It's usually something like this. All right? So k is a negative 3. Okay? And now that we have this set up, the procedure here is pretty simple. Okay? So, we are going to add down. I add down, 1 plus 0 is 1. Then, I multiply over, so I'm multiplying by a negative 3. So I get negative 3, of course. Then I add down. 0 plus a negative 3 is a negative 3. Okay? Then I, again, multiply over. So times negative 3, and I get 9. Okay? Now I add down and get negative 1. Multiply over times a negative 3, and I get positive 3. Add down, and I get 1. Multiply over. So times negative 3 is negative 3. And finally, I add down, and I get 1.
And that's your remainder, right?
Okay? And the final value is going to be your remainder. Notice on all of these, I had an x to the fourth. I'm dividing by an x. So my highest power ought to end up being what?
X cubed.
X cubed. Okay? It should be x cubed. So notice all the powers down here at the bottom are going to be 1 less. These are the coefficients of the terms that have a power that are 1 less than what you started with in that column. Okay? So my answer here is going to be a 1x cubed minus 3x squared minus 1x plus 1, and then what was below the constant term is now going to be our remainder. So it's now plus 1 over x plus 3.
Why is it 1x cubed? Wouldn't it be 1x to the fourth?
Well, because we're dividing, all right? This already was to the fourth power. And if you break this whole problem down, essentially we've got something x to the fourth divided by something with just an x. And an x to the fourth over an x becomes an x cubed. Okay? It's going to cancel out a power on every one of those terms.
So So is it always gonna be one less?
Yes.
Okay.
Yes. Okay. Now, I want you to get to the point with this procedure that you can, get through it pretty quickly. I want you to be so comfortable with it that you're really not having to think too hard about the process at all. Okay? The adding down and multiplying over. That needs to kind of just become second nature to you. All right? Let's practice another one. We're going to practice a couple of these. All right? I want to kind of show you kind of where you need to get with this. All right? So here, first of all, what's k?
-2.
-2. Good. Again, because it's x minus k, it's going to be the opposite of what you see there. You see a +2, it's -2. Okay? So now we list the coefficients. So we have a 7 in our x cubes, and then the coefficient of x squared is? 0. X?
0.
The constant?
3.
3. Okay? And now we just get to the point where we're adding down, multiplying over. So we bring down the 7 times -2 is -14. Add down -14 times -2 is a positive 28. Add down, we get 28. Multiply by -2, it's a -56. Add down, we get a -53. Okay? If you leave things nice and spaced out, you might be able to fit the powers of x in there, or you can just rewrite it here. We would have 7x to the...
2. Huh? Second.
Which is it?
Squared.
It's going to be the second power, right? We started with x cubed, and we're dividing by an x to the first, right? So it's going to reduce that power by 1. So 7x squared minus 14x plus 28 minus...
53 over x plus 2.
Very good. And notice here, because it was just a number 53, it doesn't matter if you put plus the negative or if you just put the minus out in front. Okay. All right, one more practice on your own. I want to throw a couple curveballs at you here, okay? So, let's try this one here. Okay, x to the 4th minus 10x squared plus 9 divided by x minus 3. Okay, give that one a shot on your own or ask a friend for help. See what you can do with it. So Nadia listed the coefficients here correctly. We were missing the x cubed and the linear term. Okay, so she has placeholders in both of those spots. Alright, so 1, 0, -10, 0, and 9. We're dividing by x minus 3, so k is positive 3. Okay, so we bring down the 1 times 3 is 3. Add down to get 3. Multiply by 3 to get 9. Add down to get -1. Multiply by 3 to get -3. Add down to get -3. Multiply by 3 to get -9. And then add down and we get 0. Okay? We get 0. So there is no remainder. And notice again, we started with x to the 4th, so this first term is going to be x cubed plus 3x squared minus x minus 3. Okay? Any questions? All right. Good. Ooh. Okay. Now, I want to actually take a look at this and take this one step further. Okay? Let's say that we had a polynomial that was a little bit, or we had a division problem that was a little bit different than what we've dealt with already. Let's say that we've got...
Should we write this down?
Sure. Let's say we've got an x cubed plus 5x squared minus 7x plus 4 divided by a 3x minus 12.
We can't use synthetic.
Okay, why not?
Because 3, it's not 1.
We can take
3 is not 1. That's right, okay?
Oh, it could be 3 times x minus 4.
Okay, there we go. And that's the connection I want you guys to make. We can take this and we can apply this a little bit differently. If we, instead of having a 3x minus 12, if we treat this as a 3 times x minus 4, okay, we're dividing by 3 and we're dividing by an x minus 4. Okay? So how could you do this? Samantha?
1/3 x cubed, 5/3 x squared. You basically distribute the 3 as you're dividing and then use that as your coefficients for synthetic division.
Okay, we would divide everything by 3 first and then use synthetic division with the x minus 4. Or vice versa. You could do them in either order because you guys can see here multiplication is commutative. So it doesn't matter if you're dividing by the x minus 4 and then dividing by the 3 or the other way around, okay? But that's exactly what we would need to do. We need to treat this into 2 steps, okay? It really doesn't matter which. So, like Samantha said, we can make this a 1/3 x cubed plus 5/3 x squared minus 7/3 x plus 4/3. And now we're going to divide this whole thing by an x minus 4. Okay?
Wow.
And now we can do the synthetic division because now we have something where the coefficient of x is 1 and it's linear. Okay? Yes?
It would be easier just to do log division right off the bat, wouldn't you say? Could you do that?
To do long division?
Yeah.
Yeah. I don't know. Personally, I don't really like long
I don't like
division.
fractions, so I
But-
don't use.
Yeah, I'd probably use log.
So, well, let's look at the different strategies here, because this is something that you guys have to figure out for yourselves. What strategy am I going to use? Okay?
Like, not one of those works out well, it's all like,
No, they don't. So here we've got a 1/3, a 5/3, a negative 7/3, and a 4/3. And K is what in this case? 4. Alright, so we add down 1/3, multiply by 4. So here's 4/3.
3.
So now we have 9 over 3, which is 3. That works out nice. So now we have a 12. Okay? Negative 7/3 plus 12.
Which is just going to be.
That's going to be 36/3. So 36 minus 7 would be 29/3, right? And then times 4 would be 116/3.
Yeah, that's a lot.
And then you add down, and you get 120 over 3, which happens to be 40.
That works out.
Okay? So what you end up with here is you have a 1/3 x squared plus 3x plus 9 2/3 or 29/3 plus 40 over x minus 4. Okay? So that works. Okay? Now, I told you the alternative was to do the synthetic division first and then divide by 3. Personally, I think that might be the easiest route to take. If I did synthetic division right off the bat, my coefficients would be 1, 5, negative 7, and 4. K, I'm still using 4. So now I bring down 1, 4, 9, 36, 29, and 116 and 120.
Divided by 3.
Okay?
40. I like
Now
that.
I've got to divide all those by 3. Okay? So here's the divided by 3 part.
Oh, that's so much easier.
And you'll notice that'll get me there.
4th. Oh, yeah. No.
Okay? So yeah, you've got the 9 over 3 to get the 3. You've got the 120 over 3 to get you the 40, which then you would put over the x minus 3. Okay? Either way works. Okay? The key is, what do you see? Neither of these are incorrect. One might be a little more efficient, but that's okay. Alright? The one last thing we're going to run out of time for, but the one last thing I want you to think about too, we could also use this in a context where you are not necessarily given a linear term to divide by. For example, and this one may not come out evenly, that's okay. If we had an x to the 4th plus 5x cubed minus x plus 7, something like that, divided by, say, an x squared minus 9. This probably would be easier to use long division for unless you knew it was going to come out evenly. But what I could do here is I could rewrite this x squared minus 9 as an x plus 3x minus 3.
Then would you do it twice?
And then I would do synthetic division, and then I would do it again with the result I got from the first synthetic division. So I would divide and then divide that result. It's kind of like if you want to divide by 4, you can just cut it in half and then cut it in half again. That's all we're doing there. Okay? But that's another way you can use synthetic division in a situation where initially you can't use synthetic division. Okay?
Okay.
All right. Have a great day, guys. I'll see you.